Okay, I shall introduce myself, but just very quick. Has anybody heard of Switch? Okay, for those who haven't heard of Switch, have you got EduRoam right now? If your EduRoam ever works when you're in Budapest or Bologna, it's connecting via us. So we're doing the research network and services for Switzerland. So about me, I am not Swiss. I'm Irish. I also worked for the Irish Research and Education Network. I have been working in IT for, well, since about 2001 was my first full-time technical job. I became employee number 13. And one of the first things I thought is, we should really have some documentation here in case employee number 2 gets hit by a bus. So for a lot of my tech career, I have had a foot in 2 camps, technical and not technical. I originally studied medieval history, and then I went to study computer science, where the keynote this morning gave me some wonderful flashbacks to all these business students and history students who were converting to computer science, and then there were these things called variables. And trust me, the problems didn't even start with is this a fixed number that we just have to find out or not? I will say one word, and it's nint napples. Because people didn't even know which was the variable declaration and which was the value. So I'm one of those people who likes to know within systems what can possibly go wrong. And that's why my job at the moment is reliability engineering coach at Switch, where I help teams to determine weaknesses in their system from a reliability point of view and what to do about them. And the thing about reliability is, it's really all about the human factors. The technical parts, the programming, the systems, the applications, they mostly only fit up here in the operative part. They're generally finite, generally simple. You turn them off, you turn them back on again. Normally it works. Where everything can possibly go wrong is in the 3 other fields, and that's where the humans are. So what I'm going to do today is take us through some systems, practices, methodologies, theories, one in each section. So one about governance, one about relationships, and one about individuals, and sort of learn about how the human factor impacts your ability to develop within a company, the ability to scale within a company, whether you're looking in the future at founding something, being part of a startup, or going into a much larger company. These are different tips and tricks and ways of working that will help you protect yourselves and also help your organizations grow. Does anybody recognize these sentences? So, individuals and interactions over processes and tools. Working software over comprehensive documentation. I have a problem with that one, I'll tell you later. Customer collaboration over contract negotiation, and responding to change over following a plan. Does anybody recognize them? Hands up if you do. Hands up if you learned that during your course. No. This is an extract from the Agile Manifesto. This evolved out of a ski trip in 2001 and was a response to basically the industrialization of software. And it was felt that there were so many processes and needless checks and balances that were hindering development that a different way of working had to be found. So process and tools versus individuals and interactions. More nuanced implementations of this say it's over, not at the complete expense of. So you can still have processes and tools, but it's about how the individuals use them and the interactions you're enabling, not the tool itself as some form of magical ability to connect everybody. So working software over comprehensive documentation, that is, we need to move forward, we need to demonstrate something, we need to be able to show what it is. So this is baked in as part of the governance ideas behind the Agile Manifesto, that human things are there. I have an issue with the working software over comprehensive documentation one, because I think it's got the human part flipped wrong. And we need to talk a little bit about what's meant by comprehensive, because it is very hard for us to design something without writing it down. It's very hard for us to properly negotiate as individuals about what an idea might be or where it might go without writing it down. So I would actually say that documentation is intrinsic to working software. So I have a problem with that one, but the others are all good. Does anybody recognize this? It's another three-word idea which is often thrown around about software development. So we do our most effective work as human beings if, as part of our work, we have autonomy, mastery, and purpose. This is from a book written in 1976, so it's as old as I am, called Drive. And the idea is, again, build projects around motivated individuals. Give them the environment and the support they need, and then they will get the job done. So it's all carrot, no stick. If you want to be a little bit controversial, and you will not hear tech bros saying this, Karl Marx said something very, very similar a long time ago about the conditions also experienced by workers in weaving factories. So the alienation of the individual from their labor. Oh, look, autonomy, mastery, purpose, but don't tell the tech bros. So when you have autonomy, mastery, and purpose, how do you actually organizationally enable that? How do you make it happen? This is where we start to swap from the governance part into the relationships and individuals. So I'm going to show you some models here, but here's another sentence which is probably familiar. All models are wrong, and some are useful. I'm going to show you something here where there's been a lot of debate around the truth of it, in the sense of the exact numbers where it comes in, but nobody's actually debating the principles. So remember that if you go down a rabbit hole that somebody's bringing you down with an argumentation about details, you know, is it the details that matter here, or is it the big picture? So the first one, 2 pizzas. Has anybody heard of the 2 pizzas rule? This is from Jeff Bezos, back when AWS was growing. And he made a rule that every internal team should be small enough that it can be fed with 2 pizzas. Now, Jeff Bezos, in among all the tech guys, is renowned for being frugal. Not quite as frugal as the Ryanair guy who wants you to steal your own pens to work. But this is not one of those Amazon cost-saving measures. It's about feeding a 6-person group. By the way, that's how much an American pizza, each pizza is 3 people. Within a 6-person group, every individual then has 15 different relationships with people. And that's roughly about the maximum that we can cope with as small groups to work together really intensively, to have shared mastery. So that if you say something, you know that the other person is working with you often enough and at a frequency that is common enough, they can actually understand what you really mean by that. Once you start breaking beyond that number, you have to start bringing in additional measures like more documentation, like more syncs, like more liaison in order to make it work. So, what does that mean? One of the things it means, and this is a challenge to the autonomy part, is you have to design whatever software components you're working on in your organization to fit that team maximum cognitive load. And here you've come into a little bit of a challenge, because on the other hand, something like Agile is telling you, oh yeah, you have to have end-to-end ownership and the team owns a lot of the stuff. But then it gets too big. Oh no, what do we do then? Architecture. So the model I mentioned earlier is in and around something called Dunbar's number. And this was a series of studies that basically looked to work out what way and what kinds of relationships can we have as humans at different scales. So like I said, you can quibble with the exact numbers, but think about the principles of the trust. So 5 people, they say, can have close working relationships. 6, 5, doesn't matter. I've seen it work up to 7 with very high aligned. Once you go beyond that, there tends to be a lot of coordination effort from one person in the team to keep everybody aligned. Up to 15 people, you can get deep trust. 50 people, mutual trust. So that's a small to medium enterprise. Once the organization you work for starts going above or touching that 100 to 150 barrier, there will be people you work with who don't know what you do, don't understand what you do, don't realize the value of it. And so therefore you have to find ways of explaining that as a team or as individuals. So for architecture, components where people work together a lot, small teams. Components where there is a very deep dependency, like a strong API dependency that cannot be easily abstracted. Or not even an API, actually. If you're talking about this team here is running a particular set of systems and you have to have driver access to that. You basically have a shared responsibility. You want a lot of mutual trust there. Those can glue together. As soon as you start getting bigger, you have to work with abstractions. And these abstractions is why, for example, something like cloud computing is very, very standardized. You take from Microsoft, from Google Cloud, or from AWS exactly what that specification is. And you have to live with it. You cannot change it. Take it or leave it. If you want to do complex things with it, you have to assume within your team the responsibility for that complexity. Older models, where, for example, you would work with an enterprise provider, they would allow you to outsource some of the complexity of that to them by basically paying more in a bigger contract. But this is where it goes. Human trust translates into technical boundaries. So how can teams work together if there's all of these limits? Well, there's different kinds of modes, according to a methodology called team topologies. Has anybody heard of team topologies? No. You're nodding a lot. You can come stand here too, that would be cool. So team topologies is also evolved in the last couple of years from some of the people who were around at the start of DevOps. And what they realized is that you need a bit of nuance to how you organize DevOps teams. DevOps, I'm going to be very historical here. There was nothing but DevOps when I started doing technology. There was no separate development and operational teams. The environment was not really mature enough for that outside of places like IBM. Then came industrialization, and I thought, oh, well, we need to separate the developers and the operations so that it's more secure, or so that they can specialize, or so that they can go functional. And then what they found was, well, what developers were developing was not in any way related to what needed to be operated or needed to be used. So they put it back together again. Except there still remains this tension that a great deal of complexity has come in to what we need to do to run systems and operations. So the team topologies guys have sat down and gone, okay, well, maybe there's different modes in which we can interact. So I covered the middle one, the X as a service, which is the classic cloud model where you take it and that's it. There's a couple of others, which is collaboration, where you have a close working relationship, or facilitation, maybe for a short period of time, a consultant comes in, boosts you to a level of knowledge, and then moves on. But there's traps involved in all of these, because unless you basically know where your complexity lies and know where the complexity is being taken on, you can get it very badly wrong. So if you go, we'll outsource everything as a service, yay, good. Oh, we forgot we have all of these custom parts. No, it's not actually going to be cheaper. So that's one of the challenges there. Or to put it another way, your abstraction is my complexity. There is always a certain amount of mess under the carpet. And with all of these models, all we're doing is moving it around. So what can you practically do to manage your complexity factor in terms of relationships? For each team, basically 2 to 3 small, simple things to run, or 1 big, complex one. If somebody is context switching, this is really on a human level, for every context switch, you lose 40% of your productive time. 40% of your productive time. There you go. Well, we can't be productive all day anyway. That's not human. So don't over-optimize too much. But you then also get 20% context switching. So the more things a team does, the less efficient they will be. If you go 3 times, it goes even more. So some of us don't realize that till quite late in the career. We think that we're quite good at multitasking, and actually it finds out we're pretty bad at concentrating. So this is also a case for neurodiversity. As human beings, people who have ADHD may not realize, for example, that they're not multitasking. Okay, moving to the third part, individuals. A lot of what we do in a day-to-day basis within teams is make decisions. Big ones, small ones, important ones, not important ones. And making decisions is a very human thing. A computer does not make a decision exactly. A computer calculates. We then, as humans, decide if that decision stands. And this is where we go into neurobiology. So whenever we as human beings get an alert, and this might be a sudden trigger to make a decision, it might be to respond in an incident, it might be to decide about an important change, it might be even a career-based thing. When this happens, our sympathetic nervous system gets triggered. So this is just basically fundamental biology. This is the same fundamental biology that made us run away from lions and tigers. The amygdala releases a signal, out come hormones, stress hormones, so that's adrenaline and cortisol, and cool, that's our biology. There's a couple of different responses that can happen in return to that. You've probably heard of fight or flight. I don't know if you've heard of freeze. This is one that happens basically when neither fight nor flight seem appropriate, or also it can happen in moments of persistent stress. So basically, if you're on the edge of becoming burnt out with things, the only thing that's left is freeze. So, thank you, body. Thank you, hormones. This is great for escaping tigers. It is not really very good for working out what happened in my Kubernetes cluster. Fortunately, it's a self-regulating system, because as all of these hormones are ramping up, there's a check. There's a check that goes, am I, at this point, still in danger? No tiger, just configurations. Okay, kick in the parasympathetic nervous system, we're good. This then allows your brain to settle and to get into a different kind of thinking. Now, the problem is, in IT, things break, things go wrong. And nowadays, they break and go wrong much worse than they ever did. Everything used to be a lot more unreliable, but it was generally fairly simple to fix. It used to be that one link going down in a network was a catastrophe. Now, one link going down in a network is barely noticeable. But when things do fail, there is so much complexity, so much dependency, so much resilience built in that entire systems can lock up. And when that happens, you can end up with multi-day outages, multi-shift people responding, debugging, doing complex work, trying to work out what the hell is broken now. And so during this, the stress part bounces. Cascade failures is a beautiful one. If you have a large system with many people using it and you think you fixed it, your fix can actually cause it to break, as all of the retries that have been sitting there waiting to queue hit you all at once and knock it all down again, for example. There will be angry customers. There will be context switching between handling these angry customers and handling the code base. So constant reaction will go. And also, you will probably have some emotional responses to this too. So what does this mean practically for working with computer science? So has anybody heard of Daniel Kahneman? Yeah. There's been a little bit of controversy around him recently. He endorsed some studies that perhaps he should have looked a bit more carefully. But on this one, I think it's still fairly sane. You have got two types of human thinking: fast thinking and slow thinking. So fast thinking is the type of really unconscious things we can do. Examples of this type of systems one thinking are add 2 and 2 very quickly. You're driving along, you can read a basic road sign. Or you can identify an alert. You can't really do, as a human being, anything more complex than that in the system one, fast thinking. And if you remember that curve, the upward part of that curve is all system one thinking. That is what your brain is capable of doing. What your brain needs to do to make a complex decision in computer science is slow thinking, which is complex. And it's very conscious. And one of the differences, it's way more reliable because it's got checks and balances. It's not just an instinctive response. So we need to somehow moderate and manage our stress response cycles. I don't mean prevent them, so that we get into the slow thinking phase and we're able to work there. When you are in fast thinking, there are some things that we can borrow, especially from emergency services. They did a great deal of this thinking in the 1970s and 80s. And it's about knowing the shared purpose. Having processes. Oh, look, processes are not evil. They're good for this part. Having playbooks, and above all, practicing, drilling, until what happens is no longer something that automatically triggers a stress response or an alert, but it's just a routine. So this is also why incident response drills and things like that are really, really quite helpful. Another thing is we can reverse the loop. So we know stress has got an impact on the body. So then if you tell the body, actually it's okay, chill a bit, that has the effect of bringing the stress response down. Breathing. Anybody do yoga? You don't have to admit it in public, it's okay. There's simple breathing exercises. Breathe in for 5, count, hold for 5, count, breathe out for 5, count, hold, count. If you do that 2 or 3 cycles of that, it automatically calms your body. And you can do it literally while you're sitting at your desk and nobody will notice. In long duration incidents, and I stole this one from our security response people, you have to eat. This is something I've seen a lot where people go, oh, if I just push through my lunch break, I know I will find the answer to this. Except, no, you didn't, because you're too hungry and you can't concentrate. Eat. I am not a fan of overnight maintenance. This used to be a thing. It used to be, oh, we better do all the work while everybody's asleep. Well, first of all, people use things 24/7 now. And second, shift work is really bad for human beings. Overnight shift work is terrible. So you need to, if you cannot avoid it, and you're going into a change scenario with that, you want that one really, really well reviewed, documented, and listed out with the commands to run and the expected output, because otherwise nobody's going to be awake enough to debug it properly. And then the final one, which I'll come to now, is about the emotional burden of all of this. Once upon a time, I did a lot of training courses as a receiving end about how to deal with conflict in organizations, how to handle problems. And it was all, if you're German speaking, fachlich und sachlich. So basically, you could solve every single problem in the operational space if you just didn't mention the fuzzy stuff. This is wrong. This is so badly wrong, it is actively dangerous for you as a human being and also for getting anything done. So an emotion is literally just a signal. It's a signal about something. There's no such thing at this point as an incorrect emotion. So if you're getting a signal, what's the worst thing that you could do with it? The worst thing you do with it is suppress it. Don't suppress it. Acknowledge it. You know, geez, I'm really fucking pissed off that this happened again. Oh, I feel a bit better. As individuals, we're often conditioned by culture not to show particular emotions. As a woman in tech, I can tell you, you show an emotion in front of some people and you're cursed forever. These are bad people. You don't want to work for them. But generally, what happens if we suppress an emotion is it just grows. And then you don't get to settle and you don't get to work. So observe it, name it, work out what it's telling you that you need. And then see if you can formulate a concrete request on that. And the little request might be, look, I just need 5 minutes, I'll be back. Or it could be, I need us to work together on this because we broke it together, or something like that. But there's a thing, an emotional is a signal, and it's connecting to a need, so follow the need, and then you'll find something that helps you resolve the issue. And finally, and this is a next step into the other parts of human parts, how do we improve? How do we get better at anything? We get better at things by making mistakes. It is much easier, well, it's not much easier, it's much harder. It's much stickier to learn from something you did wrong than something you did right. And so emerging, especially from reliability and site reliability engineering culture, is something along the lines of blameless culture. Now, there's a lot talked about this in very, very big, how shall I say, hype in the reliability engineering space, which is partly because a lot of the culture around tech comes from US firms who have hideous individual worker rights. So people can literally be fired at will. And so therefore, building a blameless culture in that kind of environment is an act of bravery. It's somewhat easier in the EU, where people cannot be fired at will, but it's still really important for the glue that holds the team together and for the team spirit to have a blameless culture. And that is not the same thing as not taking responsibility. But it's about getting to what was really the root of the problem. Because in today's IT systems, if you have a problem that can be traced to one human error, then the problem is probably not human error. It is probably a systemic failure to put in a guardrail, to put in something else. I mean, we have fire escapes here. Once upon a time, they didn't exist. They came in because people looked at, why do people die in fires? Let's have doors that open. Let's have lit ways to go through them. Rather than, oh, no, I think we should all adopt personal responsibility to escape from the flames. And IT is now maturing in this way and slowly moving away from the culture of personal responsibility to collective parts. But this can only be done if human beings are open and if human beings accept that error happens. So it's not non-accountability, it's about understanding the real structural problems and working on them. So I'll leave the last word to Yoda. We are human. We will fail. Failure is not a problem. It's how we learn. So that's the speaking bit over. Sorry, I have to have this. Don't worry. But I will say any errors in it are my fault, not my employer's. Does anybody have any questions?
You don't need to be shy, but I'll give you a bit more time to think about it, and I'll give you a question. Yeah. So thank you for the talk. It was quite interesting. I got the feeling, well, you really focused on companies, but I think what interests me more, or just as much, is open source communities, right? Because these are huge, massive things, and the open source drama sometimes is really entertaining to outrageous. For example, Linus Torvalds is used to be quite, yeah.
Is the microphone still on? I have met Eric S. Raymond, and literally all he did was talk to my tits. There is a massive problem in open source, but there's also massive opportunities. I mean, the community concept is brilliant. The idea that something does not all have to be about a profit has a great deal of potential. But man, the gatekeeping is awful. And I noticed that there's such a strong feeling from many of the early founders and early people involved in this that they were the outsiders, that they cannot possibly see themselves now in a position of privilege and literally don't know how to work with that. But yeah, it's a tough one. I'm not sure how to do it, especially because most of it is volunteer. And if a volunteer gets a hard time, what's keeping them there? Yeah, it's a very good question. I have no answers, but...
Thank you. Do we have... Yes.
So you talk about like putting small teams in place that take care of specific domains, but as you said, like systems are getting so complex, and when something fails, a lot of things fail at the same time. So at this point, how do you get all these teams together to fix the problem together?
Okay. So once upon a time, there's a thing invented called ITIL. And it said, we have to have very strict processes for all of this, and we have to organize this, and there have to be change advisory boards for this, and there must be a defined incident manager for that. Recently, they threw out almost all of that. And what they say is, in an incident, what you need to do is not get hung up on hierarchy and call in who is needed, swarm. And this is actually something where I think, honestly, COVID lockdown helped a lot. So during lockdown, it got away from all of those ideas that we have to meet physically, that there has to be organizational norms around this, and you have to send out an invite and whatever. Now you can just take a Slack channel or a Mattermost channel at who you need, and they may turn up. So that has made that kind of thing, pulling together the right people quickly, much, much easier. It's removed a lot of barriers to it. But you do need also the organizational barriers. And then it's just, are they open-minded enough to work together? Is the incident manager emotionally aware enough to detect tensions and work with them? But generally, if the company has a shared purpose and the priority is visible, people will turn up.
Do you follow up? Yep. Okay.
Thank you for the talk. So I'm interested now that you mentioned the comparison with COVID and using kind of remote communication methods. In your experience, especially now in the case that you need to bring in larger groups of people to work together, does a Slack channel work just as well?
Yes and no. For our scale, it does. I was just at VIScon 2 weeks ago, and they presented about a massive incident. They had a Datadog. And they ended up having something like 71 Slack channels, with one person literally just circling around all of them, boosting the next info thing, and then bringing people into the other ones. So it does. It's in fact the only way to properly scale multi-country and multi-time zone. But yeah, there's limits in it, and the limits have to be bridged with human glue.
Thank you.
Those presentations from VIScon will probably be online in about 5 weeks. And there's at least 2 on big outages, which are definitely worth watching.
So thanks for the great talk. I have a question about a lot of companies really want reliability, but when it comes to it eventually, they don't want to pay for it.
Yes.
How do you handle that? How do you communicate that? Because presumably a lot of the time they would bring you, for example, in,
Yeah.
and then after a while they figure out, actually we don't have the budget for this, or we don't want to budget for this.
Okay. Well, the nice thing about Switch is it's sort of baked into the beginning. We're not there to make a profit. And the fundamental principles of the company are secure and stable services. But even then, there's an awful lot of taking reliability for granted. We have our IT strategy, and it mentions efficiency a lot, but it mentions stability twice. And it's basically, we will have DevOps teams, and everything will be secure. And then I came along and said, okay, that's nice. How? And I also think that maybe the SRE team part in Google and the rest emerged from this whole, oh, actually, no, we do need sets of paranoid people to take care of this kind of thing. There's a couple of different techniques. One is basically asserting that reliability is customer feature number 1, which it is. Nobody's going to pay for something which is not reliable. I think this is currently being tested. If you look at the massive US company layoffs, they are basically peeling away people until they can see what breaks. So I think that's currently being tested. And then another one is to do some complex mathematics to say, what is the value of the next feature versus the value of reliability work here? And again, allegedly there's mathematics, but I don't think that people really make data-driven decisions. Certainly at companies up to 250 people, they say they do, but it's all gut, is my personal opinion. So basically, you can best hope for making an economic argument or making another. And then the next one is use every incident and outage mercilessly.
Thank you.
I think I'll sneak in another question. So this talk was quite insightful, but let me put it this way.
With an S or with a C?
Well, I think it's an S. But, what can we do, or what can, for example, a university like ETH do to actually foster these skills? I mean, they say they do, but realistically, they just give us say, do this, find a group of 5 people and work on this.
Yeah.
And, I mean, you can't just also give, you can't give, like, for example, a high schooler a textbook and tell them, you learn this. I mean, that's not how it works. So do you have any suggestions on...
Sorry, I missed the last sentence.
Oh, you can't just give, like, a higher mathematics textbook to a high schooler and expect that it'll work. Like, they'll, like, learn this. This is not how it works. You have to teach. Do you have any thoughts on this? Like, how can universities do a better job at teaching these skills?
Yeah, I think this is a very good flip from this morning's talk, where the keynote was saying we need to get computer science into the other disciplines. I think we also need to get some of the other disciplines into computer science as well. But again, it's exactly the same challenges. How much of the curriculum do you put on this and all the rest? Universities actually have the people who can do this. Harder, actually, maybe in places like ETH, where it's so strongly technically focused. Where I went to university, it was more generic, so because Ireland does not focus so deeply in technology in one particular institution, so you could have cross parts. But yeah, I also think maybe before you go out into the workplace, some coaching also on the human factors. I mean, loads of coaching on how to be an entrepreneur and how to found stuff and how to develop your business, but what about how to keep you safe as a human being? That would be quite nice. You can learn the other stuff out of books.
Thank you. Any other questions? I think we can, yeah, we have still 4 minutes left, so we have time for a few questions.
Yeah, sorry if I spoke very fast. I am Irish and I'm back from Ireland about a week, and we speak very quickly there.
Thank you for the talk. I have a question about this, like, emotional aspect you mentioned, or the blameless culture development that you like observed, especially in site reliability or reliability engineering. Do you also have some perspective on how this development is happening in software engineering, where there's not such a big, like, high pressure situation or environment?
Okay, so the first thing is for SRE, that is really the bridge between software engineering and classic sysadmin, sysops stuff. So I tend to come more from the sysops side, so I don't have that much insight into software engineering. What I have observed outside of the company is I think there are some cultural difficulties in software engineering. I think in some places, in some spaces, it is extremely elitist. Also within the organizations that run software services and the others, and there's this tendency to go, we are the proper engineers and the rest of you are not, and I don't think that is helpful. But I don't have enough insight to say, are cracks starting to show in that, because that's not my space.
Mm-hmm. Thank you.
I expect they will eventually, because this kind of thing is human. But yeah, it's very elitist, and when something is very elitist, people are trapped inside a system where they believe in its own worth for a while until it breaks. Ja, wir sind fast fertig, ist gut.
Yeah, thank you very much.
We have 1 minute left, so if anyone has a super short question, a super short answer, we can still do that. If not, thank you for the questions. Thank you again for the talk, and
thank you for being a very cool audience.
That's all. Thank you.